So to the last lecture, that is lecture number 4, we just give some example of equivalent relation and the opposite relation and some definition related to the opposite, comparable, uncomparable, and so on. When we study the opposite, it's a very important topic for everyone to learn the Hasse diagram. When we study the PCC, in that case, it's too much calculative in the field of abstract algebra. In that case, there is a basic concept which is very important for student is visual concept. যদি সেটাকে ভিজুয়াল করা যায়, ছবি আঁকা যায়, তাহলে যে কোনো জিনিস বুঝতে অনেক সুবিধা হয়. So the visual device used in the study of PCC is the Hasse diagram. What is Hasse diagram? In this lecture, we want to learn the Hasse diagram, the way of representation or drawing of a PCC using Hasse diagram. The name after the Helmut Hasse, a 20th century German number theorist. He is a number theorist. Very important is that he is a number theorist, known as number theorist. Is Hasse diagram. Again, we repeat this line. Hasse diagram is the most valuable and important diagram to represent a PCC. It's a visual device. Okay, so before we draw the Hasse diagram, you have to learn what is the meaning of cover. Cover is, now it's a period of COVID-19. So when we open any media or any radio audio division, or when you call someone by phone, in that case every company give a free suggestion for you for better to your better health and the protect COVID is to wear or cover masks, cover your mouth by a mask, and cover your hand by an gloves and so on. As much you can cover, that means বাংলায় বললে ঢাকা, ঢেকে ফেলা. What is the meaning of ঢাকা or cover in the concept of PCC or in the concept of the field of abstract algebra? Let S be a PCC with the relation less or equals to be a PCC and x comma y belongs to S. We say that y covers x. আমরা তখন বলতে পারবো y x কে কভার করেছে if for x is less or equals to y but x is not equals to y and there are no element z belongs to S such that x less than z less than y. It's very important. So if we consider the previous example here, if we consider the previous example comparable or non-comparable, in that case, if we consider here another set, okay, just clear your concept using this particular example. We have already learned this. Here we consider the another set, say A3, okay, another element of the power set is A3 equals to, say it's 1, 2, 3. Okay, so according to the cover definition, A1 is a subset of A3, subset of A3. Okay, sorry, I miss A1. A1 is a subset of A3, but we cannot say A3 cover A1. Why? Because there is a set A2 which represent A1 which is lesser equals to A2 lesser equals to A3. Okay, so According to the definition of cover, if A3 is the cover of A1, that should not be happen that there is another member belongs to the set which can cover the element A1, which can comparable with the element A1, which is lies between A1 to A3. In that case, we cannot say A3 is a cover of A1. But if we consider this one, A1 is less or equals to, according to the set inclusion principle, A1 is a subset of A2, but there doesn't exist any other set lies between A1 to A2 which should be comparable with A1. So in that case, A2 becomes the cover of A1, but A3 should not be the cover of A1. Okay, I think it's clear for you. Next, this one. We move to this one. So I think it's clear for you. What is the meaning of cover? There are no element Z belongs to S such that X is a subset of Z is the subset of Y. Okay. Now we move to the diagramical representation of Hasse diagram. Here we consider example. Okay. Next we move the step. Draw a diagram. The first one, we draw a diagram of the poset. Okay. S is a set. According to the previous example, S is the set consists 1, 2, 3. Therefore, PS being the power set, we have already mentioned it should consist 2 to the power n. That is, n is 3, 2q, 8 number of element. One is null set, another one is the singleton set, 3 singleton set, 1, 2, 3, and 1, 2, 1, 3, 2, 3, and the last one is set itself 1, 2, 3. According to diagram, we have already learned the diagram in a relation system. That means every set is a subset of itself, so every vertex must have a self loop. Okay, so we move to this diagram. Exactly in that. Why we consider this self loop? Because every set is a subset of itself. Here we use the set inclusion relation, that means subset relation. So every vertex must have a self loop. Second one, phi is a subset of the singleton set 1, singleton set 2, singleton set 3. So phi should relate it to 1 to 5. Phi is a subset of this. Why we use this arrow? Because it's represent the relation is whole from phi to 1, the singleton set 1. Okay, we always mention the preceder to the successor. We always follow the arrow from preceder to successor. It means superset, subset to superset according to this diagram. So similarly, phi is also a subset of this one. Phi is a subset of this one. Phi is subset of this one, and phi is subset of this one. So here we consider that. Next, we move to the next level. 1 is a subset of 1, 2. 1 is a subset of 1, 3. 1 is a subset of 1, 2, 3. So we make 3 arrows from this. But 1 is not a subset of 5, so we should not mention an arrow from 1 to 5. Similarly, 2 is a subset of 1, 2, 2 is a subset of 2, 3, and 2 is a subset of 1, 2, 3. So this one is the arrow. This one is the arrow. Okay. Next, the same concept is arise here. That is known as the arrow diagram. When you construct the arrow diagram, it is too much critical according to the diagram for only 8 elements. So for that reason, when it forms a poset, we must consider the Hasse diagram. This one is the procedure of drawing a Hasse diagram. We draw a diagram using the element of S as the following. We represent the element of S in the diagram by the element themselves. Such that if X is covered by Y, then Y is placed above the X. Okay. When X is covered by Y should be the upper level and X should be the lower level. So Y is placed just above the X. Okay. We connect X with Y by a line segment if and only if Y cover X. The resultant diagram is called the Hasse diagram. That means in the Hasse diagram, we should not consider any arrow, because when we draw a line from the lower level to upper level, it automatically represents that the relation holds from this should be the lower level element should be the preceder and the upper level element should be the successor. Here we mention the procedure following step. The first one, in a diagram we place the vertex in the above vertex A above the vertex B if A is covered into A cover B in the poset this. The second one is we delete all the loops from the diagram, because it's a poset, that means we can say that a row A already satisfied, so we should not mention any self loop, because the relation here we mention this term is reflexive, then it is a loop at each vertex, so it is not necessary to show the loop, so you have to delete the loop from the arrow diagram. Next one, we do not all we delete all the directed edges that are implied by the transitive property. That means when you draw a arrow from A to B and B to C, it's represent that there is a relation from A to C. But when we draw the arrow diagram, we just make it arrow from A to C. It's for representation of the transitive property. But when you draw the Hasse diagram, we cannot represent the transitive property, because the transitive property already satisfied. For that reason, we just draw the Hasse diagram. That should be happen. Okay. So when we draw the Hasse diagram, this one should be the Hasse diagram of the given arrow diagram of the given poset. So here we can observe that phi is the least level element, which is a subset of 1, 2 and 3. That is 1, 2, 3 covered phi. 1 is covered by 1, 3 and 1, 2, but should not cover by 1, 3. So we should not make a line from 1 to 2, 3 set. And 2 is covered by 1, 2 and 2, 3. So you should not make a line from 1 to 3, because 2 is not covered by 1, 3. 3 is covered by 1, 3 and 2, 3. So we should not make a line from 1 to 3 to 1, 2, because 3 should not be the subset of 1, 2. And 1, 2, 1, 3 and 2, 3 all are the subset of 1, 2, 3. So that should be your Hasse diagram. Also, you can recognize that phi is a subset of 1, 1 is a subset of 1, 2. When we draw the arrow diagram, we just make a arrow from phi to 1 to 2. But since we draw the drawing of the poset, we should not mention here the transitive property, because when we see that phi is a subset of 1, 1 is a subset of 2, therefore phi should be a subset of 1 comma 2 according to the transitive property, and we can draw only Hasse diagram for a poset. Okay, thank you. In the next lecture we move to some another important terms, maximal, minimal and others for Hasse diagram. So happy learning.